consisting of all diamonds could be dealt from a standard deck of playing cards. Oh yeah, we'll remind you what a standard deck of playing cards is. It'll either be written on the test paper, or this will be a pop-up where you will be reminded that there are 4 suits, 13 cards in each suit, 2 suits are red, 2 suits are black, suit names are blah, 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 number of numbered cards, number of face cards, and so on down the line. So you'll be given all the dynamics of the exercise, but you're still going to go back to basics. And back to basics means you've got 6 blanks to fill in. Does order matter? Do you have to keep the cards in the hand in the order they were dealt to you? Can you shuffle them around? In the identification code, do you have to enter the numbers and digits in the correct order? See, so here there's a difference. The difference is order doesn't matter. So the 2 questions you're asking yourself is, or are, what's acceptable, and how many places can you position this item? So what do you need to get? All diamonds. So what's the total number of diamonds? So how many acceptable cards for the first digit? Or for the first card? Any of 13. Where's it going to end up in your hand if you rearrange the cards? Any of 6 places. And what comes next? Can you reuse the cards? Not if they're dealing them out of the deck, you can't. So are you down to now only 12 cards? And only 5 available places to hold it in your hand? 11 cards and 4 available places? 10 cards in 3 places? 9 cards in 2 places? 8 cards in 1 place. So now you got a bunch of multiplication problems, because in here you were dealing with an and problem. You had to get card number 1 dealt first, and then card number 2, and then card number 3. Even if the dealer put all 6 cards in front of you to begin with, you picked them up one at a time, or you touched them one at a time as you move them around. So whether you do it in pieces or whether you do it the longer way won't really make much of a difference. So we've got 13, 12, 11, 10, 9, and 8. Numerator's quite large. 123, 55, 20. Denominator, $720. And since they're talking about determine the number, then we have to do a division problem. So when we execute this division problem, we come up with 1,716 possible hands that will hold all diamonds. We don't care what the order is, but one hand will hold a different set of diamonds than the second hand will hold, so on down the line. So there again is your setup step. I don't necessarily need to see this, but I do need to see this, because this is your support for the problem. If you can set it up right, I have to trust that you can calculate it right. So I don't need to see what those totals are out there, but I certainly do need to see you set the problem up correctly. So we've seen one order does make a difference. We've seen one order doesn't make a difference. Identification codes. Lock codes to open a combination. license plates, telephone numbers. Those are all order makes a difference. But just give me cards, let me select people that are friends, order doesn't make a difference there. Officers' orders make a difference. So you can see any of those types of problems that would be involved in counting or probability. So now we're going to the dark side of the probability. One card is selected.